The U.S. Navy has several ongoing projects to detect large whales, including the critically endangered North Atlantic right whale, within areas that are important to Navy training and testing. One such project is the use of marine autonomous gliders off the mid-Atlantic states of North Carolina and Virginia to monitor for the presence of these whales from the sounds that they make. The technology we utilize can automatically detect those sounds, identify the species based on characteristics of the sounds, and report which species have been heard via satellite in near real time, which scientists such as myself can then verify. We work with marine ecologist Mark Baumgartner at Woods Hole Oceanographic Institution for this project. We utilize slocum gliders, which operate by moving up and down in the water column using a buoyancy pump. The pump only operates at the beginning and end of a dive, therefore the vehicle is silent during descent and ascent, making it ideal for passive acoustic monitoring. Slocum gliders are capable of moving horizontally at slow speeds, and they can stay out for 3 to 5 weeks due to battery life. They are equipped with oceanographic sensors, a global positioning system, and a satellite modem that allows two-way communication with a shoreside computer. The vehicle is navigated simply by providing new waypoints to the vehicle during satellite communication sessions. The vehicle is capable of self-navigating to these waypoints by adjusting its roll and yaw to change direction. We mount a hydrophone or underwater microphone on the outside of the glider. Gliders also carry the Digital Acoustic Monitoring Instrument, or DMON, a passive acoustic instrument that is capable of recording and processing audio in real time. The system produces pitch tracks of sounds, which describe changes in the frequency or call over time. Scientists typically examine spectrograms to identify marine mammal calls, and pitch tracks are derived from these spectrograms. The detection classification system can use information from the pitch tracks, such as call duration, average frequency, and uses that information to classify each call. The classification is based on a verified call library. The communications with the glider and ultimately a shore-based computer via the satellite transmission, the DMON remotely reports tallies of calls for each call type in its library, as well as a subset of pitch tracks. Analysts are trained to review the DMON data in near real time using a protocol so that the results are standardized and consistent among analysts. We just had 2 slocum gliders out off North Carolina and Virginia and detected several whale species, including humpback, fin, and sei whales. This was our second time deploying gliders off the mid-Atlantic and will likely continue the project next year. Monitoring species presence is an important aspect of the U.S. Navy's Marine Species Monitoring Program, which ultimately helps us in conducting our environmental analyses to ensure we are in compliance with the National Environmental Policy Act, the Marine Mammal Protection Act, and the Endangered Species Act.